In this video, we will discuss what it means to power a circuit as a source or sink. Initially, let's think about power. Powering a circuit requires a voltage source, a load, and a ground. Sinking and sourcing are ways of powering a circuit. Sourcing provides the voltage source for a circuit. Sinking provides the necessary ground for a circuit. As stated in a previous video called Sinking and Sourcing PLC Outputs Explained, the difference between sourcing and sinking is simply the direction of the flow of current. If we draw a picture of two theoretical devices, show a connection between them, and indicate the direction of the current flow, we can then decide which device is sourcing and which is sinking. If device 1 is connected to device 2, and the current flows from device 1 to device 2, then device 1 is sourcing, and device 2 is sinking. If we flip it and imagine the electrons flowing the other way, then we make device 2 a source, and device 1 a sink. Why does it matter? The direction of the current flow dictates whether you have a sourcing or sinking, but the actual devices chosen depend on wiring, terminal blocks, and the number of inputs and outputs that might share a common. Also, your PLC card will be specified as either sink or source, and must be wired accordingly. This is part of the thought process that design engineers take on when specifying components in a system design. Sinking provides a path to the supply common. In this circuit, when the button is pushed down and the contacts are made, the current moves positive to negative as an input to the PLC. It's a positive signal input, and the supply common is negative. Thus, it's sinking. The sinking output module will have the current flowing into it from the load. It uses NPN transistors for switching. Sourcing provides a path to the supply source. Note the change in common and button location. Notice that the input to the PLC is still a positive value. The sourcing output module will have the current flowing out of it and into the load. It uses PNP transistors for switching. In summary, inputs and outputs look like these wiring examples. What does the instrument you are wiring to require? Instruments may have PNP or NPN transistors in their circuits. P stands for positive, and N stands for negative. Positive and negative refer to the current polarity. This will determine what power sourcing needs to happen. Transistors, as opposed to relays, rely on polarity. Many proximity switches have PNP or NPN transistors today. Good design habits require wiring all I/O points with the shared common to either source or sink. This will save time, cabinet space, and terminal blocks. How so? If you wire the circuit as a block, the common can be shared and supply more than one sensor. Note that we have been discussing 3-wire sensor circuits and not AC-powered circuits. AC changes polarity naturally. DC uses transistors. Do not use an AC power supply to source a DC source sink point. Why? DC and AC do not match, and instruments will fault. Along the lines of good practice, it's prevalent to see common as negative, as seen in the sinking examples. However, it's not about better, just more common. Get it? A more common is positive. Pun intended. Is it necessary? No, nor is the pun. Most modern PLCs allow the flexibility to wire NPN or PNP, but may require doing so as a block, based on a shared common. Checking out your PLC common wiring scheme is key if you are troubleshooting or adding to an input-output card. For design, planning ahead will make sure cards, instruments, and commons match. Thus, matching the design to the application is more important than debating over whether PNP, sourcing, is better than NPN, sinking. In the end, Having planned out wiring is much safer and less costly. If you are interested in learning PLC basics, several courses, such as PLC Fundamentals for Control Systems and PLC Hardware Fundamentals, can help you. You can find the links to these courses in the description of this video. Big names like Volkswagen, Moderna, and Bosch are already improving their teams with RealPAR's industrial automation training. Click the link below for a free consultation. Learn how easy it is to train your team with RealPARs.